Hi guys, welcome to today's tutorial looking at exercise 4.7. This is from the Maths in Focus book 2, which is the red book there. This is primarily working with differentiation of logarithms, but certainly touches upon lots of other types of differentiation problems as well. Before I start, I might just look at that if I have the function of y is equal to log e f of x, then if we differentiate that, as you should know hopefully by now, that will be f dash x over f of x. So we differentiate the term, the function of f of x, and we put that over the function itself. But remember, you still need to know about your quotient rules, your product rules, your chain rules, etc. Okay, so the first question we're looking at says x plus log ex. There are two terms here. Okay, the x and the log ex, separated by a plus sign, which means we can simply differentiate each individual term. So if I'm looking at, or I should say actually d dx, because there's no y equals there. So d dx, well, if I differentiate x, we just get 1. If I differentiate log ex, using our rule on the right hand side there, well, if I differentiate x, we have 1. And we put it over the original function. So it's just 1 plus 1 over x. A nice easy one to start with. Looking at question D, we have the log of x squared minus 4. Okay, so that's the function, I guess, if we're looking at the rule log e f of x. F of x in this case is the x squared minus 4. So if I'm looking for my d dx, is equal to. Now notice how the whole function is inside the logarithm. So that basically means I'm using this straight rule. So if I differentiate x squared minus 4, well, that's going to be straight 2x all over x squared minus 4. Okay, so two very straightforward ones to start off with. Moving on now to question F, which I think is a decent question. We have, similar to the last one actually, log e 5x plus 1, so the 5x plus 1 was that f of x, I guess, but now we've got a second function here of x squared, again noticing that it is a plus sign, so there are two different functions going on, and we can simply differentiate each one individually. So the first one, if I differentiate 5x plus 1, well, that's just 5. Now my rule is f of x over, so f dash x over f of x, so it's 5 over 5x plus 1. Plus, if I differentiate x squared, we just get 2x. Okay, both pretty straightforward stuff there. The next one starts to get a little bit more challenging. Certainly this is a more challenging question. Now, notice again the 4x plus 1 over 2x minus 7. This here is my f of x. So what we need to find out is what my f dash x is going to be. Now this is a bit more challenging, this f of x, so you might want to do this part separately and then put it back into your sort of your rule. So if I look at this this part here, we know that I call this top part u and bottom part v, and this is going back to looking at our quotient rule, which is v u dash minus u v dash all over v squared. Okay, so we're going to need to differentiate that. So if I'm going to look at my f dash x is equal to, well, my and it's not actually a bad thing to do also, is to write out your u and uv separately. So u is 4x plus 1, my u dash is just 4. My v would be 2x minus 7, my v dash would just be 2. If you write them out separately, it can be a little bit easier when you're putting it all together. So if I put it out here now, I might actually put it down here because it's going to be a little bit easier. Now remember, this is my f dash x for my rule, okay, which is going to be my v u dash. So v, you can see above, is 2x minus 7. I'm going to multiply that by u dash, which is 4, minus my u is the 4x plus 1, and I'm going to multiply that by my v dash of 2. I'm going to put it all over my v squared, which is 2x minus 7 all squared. Now let's start to simplify that a little bit more. 4 times 2x is 8x, minus 4 7s are 28. Now notice there's a negative here, so this is a minus 4x times 2 is minus 8x, a minus 1 times 2 is minus 2, Again, that's all over the 2x minus 7 all squared. Notice I'm not going to expand that bottom part. 8x take away 8x is 0. Minus 28 minus 2 is minus 30 over 2x minus 7 to the power of 2. Okay, now a lot of people actually sort of stop there and they think, hey, we're done. But remember, all that has found me is what f dash of x is going to be in terms of this particular function. But we've got a logarithm. Now we know that the logarithm for d dx is going to be given by f dash x over f of x. So what we now need to do, I'll get some more room there, is we know what f dash x is. We've got that part there. So minus 30 over 2x minus 7 all squared over what f of x was. So f of x, as you can see in the question there, I'm running out of room, 4x plus 1 over 2x minus 7. Now, if you are pretty good with dividing by fractions, what you might recognize is that you can actually just flip this up. So the 2x minus 7 goes up the top and the 4x plus 1 goes on the bottom. If you're not sure on how to do that, because it is a little bit challenging, what you can do is just rewrite the fraction with a divided by sign. So that's my first fraction. I'm going to use the divided by sign instead of the over. 4x plus 1 all over 2x minus 7. Now we don't like dividing by fractions, so what I'm going to do is turn that to a multiplication, but making sure that we flip. So times and tip, 2x minus 7 all over 4x plus 1. And then, I'm going all right the way down here, aren't I? And then what you might notice, you've got a 2x minus 7 on top, you've got 2 of them on the bottom. So what we can now do is put minus 30 all over. We can cross 1 off the top, we can cross 1 off the bottom. So I'm just left with 2x minus 7 and 4x plus 1. And because it's factorized, I'm going to leave that as my answer. Okay, and that's quite a substantially difficult question. Again, if any of this is getting too difficult, certainly pause it, rewind it, and have a go again. We start getting to the more challenging functions here. Now this is what we refer to as the chain rule. Now my chain rule states that I take the power down to the front. So let's do that to start off with. So 5 down the front, we make 5 outside of 1 plus log ex to the power of 4, but my rule then states to multiply the differentiation of what's inside the brackets. Now in this particular case, we have a log ex. If I differentiate 1, it disappears, so that doesn't matter, but this log ex, I need to differentiate. So if I differentiate that, it's simply 1 over x. That 1 over x is my differentiator of the log part. It's done. Okay, don't have to do anything else now. I've simply got my chain rule completed. All I want to do now is multiply 5 by 1 on x. So you could either put it as 5 on x, brackets 1 plus log ex to the power of 4. Or you could also write it as 5 brackets 1 plus log ex to the power of 4 all over x. It doesn't matter, those two things are exactly the same. It doesn't matter because think about it, if I times the top and times the bottoms, that's all over 1, x times 1 is x, blah blah blah. So that's pretty much your chain rule, and again a lot of people keep on wanting to put this, the whole thing over what you started with, but remember the log is, it's inside the brackets. Part of my chain rule is only differentiating times in by the differentiation of inside the brackets. That's the only time I ever touch it. I know that can be a bit confusing, but I guess you just have to keep on watching it and trying these questions. We're going to have another crack again anyway, so hopefully you might understand it the second time if you haven't the first. Alright, x squared plus log ex to the power of 6. Pretty much identical question. Well, it is really, except we've got a more challenging term here. Not much more though. So let's have a crack at it. Hopefully you can have a go at this and pause it, and then hopefully you will get it right when you play it. Okay, so my chain rule. Bring the 6 down in front of the brackets. We'll do that. The function will stay the same inside, but I need to subtract 1 off my indice. Now we need to make sure, remember this is the chain rule, we now multiply it by the differentiation of what's inside the brackets. Now in this case I can differentiate both terms because I've got x squared, which is just 2x, plus log ex we know to be 1 on x. That's my logs, and we're done. So we might want to simplify it just a little bit, and realistically we don't have to do too much. What I might just do, I might write it this way and keep the first part at the end, only because I've got that indice there. Okay, I could have left it the top way and it's pretty much fine. But look, that's fine. That's all factorized. That's out nice and neat. So again, that's the chain rule for both those questions. You can see it's not that hard. You're just following your normal chain rule, but within that rule, obviously, is our new part of how to differentiate the logarithms. Okay, let's have a crack here. This is, again, a slightly more challenging question because it's using my quotient rule. Noticing that the first time we did the quotient rule, and I might just go back, I think it was it this one? Yeah. Notice how in this question here, the function, the function was within the logarithm. So this question is slightly different because if you have a look at this question, the logarithm is within the fraction. Slightly different, you may not notice it, but there is a slight difference. Anyway, I'm going to start off with my u and my u dashes. U is e to the power of x, which is an exponential. So u dash is equal to my exponential laws. Differentiate 2x, we get 2, and then remain the same. My v is going to be log ex, or ln x, and my v dash is going to be, well, simply 1 on x. Now I'm going to go back to my quotient rule, as we said that before, which was for my d dx is vu dash minus u v dash all over v squared. And now they've got all the information above, it's going to be a nice drop and play, basically, or plug and play, as I often do say. Okay, my v is log ex times u dash 2e to 2x minus my u, which is e to the power of x, times my v dash, which is 1 on x, all over v squared, which is log ex. I'll put that in the squared. All right, I have a feeling we're going to have to be going down the screen. Okay, so here we are. I'll chuck in my ddx, so it's on the screen there. Okay, so let's start to simplify some stuff. Now remember, when we're simplifying, if we can sometimes take a common factor out, that can sort of help us. At this stage, I've probably got an e to the power of 2x there that I can take out. You might say we've got an x there, but that might be a bit more challenging. So I'm just going to start off with e to the power of 2x out the front. So in brackets, what I've got left here, I've got 2 times log ex minus, I've taken the e to 2x, 1 over x left inside the brackets, all over log ex squared. Now, to be honest, I'd probably leave my answer that way. I know for those of you checking your answers, it's written slightly different. What their answer will be this: e to 2x brackets 2x log ex minus 1 all over x times log ex squared. Now, if you notice the difference, what the difference is they've brought the x down the bottom, right? It was 1 over x, which is the same as what it is now. That's fine. That's the same thing. The problem is they've added this x in here. Why? Well, what's x divided by x? Because remember, if the x is on the bottom, it has to go divide both of these terms. If you look on this side, only one of them is being divided by x. So I need to put like an extra x in there, so then these ones actually cancel out if I separated it. It's a bit confusing, to be honest with you, hence why that one I would probably accept. Okay, so don't be worried too much about that. Okay, look, we're nearly at the end here, guys. I know it's been a fairly long tutorial. We've got 2 more major questions coming up. So these are the more applied questions. We've just looked at how to differentiate. Now we're seeing how to then apply that differentiation process. And that part doesn't change. Remember, any times they ask you to find the gradient, well, that's just really fine, asking you to find the derivative, dy dx. If they want the the value of the gradient, then we simply sub in the x value, because as you recall, of any equation, and this is no sort of different, which will be for a logarithm, it's kind of like that. At any particular point, my gradient is going to change, and you can certainly see when x is, let's say, 1, for example, that's a lot steeper than what it is when it's maybe like 5. So we need to have an actual point to sub in to find the gradient, because the gradient will otherwise will keep on changing. If they want you to find the equation of the tangent at that point, then once you've got your gradient, just put it back into the y minus y1 equals mx minus x1, and be careful to ask you to find the normal, because that's the perpendicular one, which is the m1 times m2, because -1. Okay, but what does all that mean? Let's have a look at this question. Find the equation. All right, the first part is it's asking for the equation, so I'm going to need to find number 1. I need to find the gradient first, and then number 2, I need to use the y2 minus y1 equals mx minus x1. So the first two things I'm going to need. They do give me the point, my point there, so that's fine. So I can put that straight into that formula later on. So let's have a crack and see where we come up with. So dy dx, dy, because I've got y is equal to. So if y is equal to log ex, well, hopefully that's a nice easy one, because dy dx is simply 1 on x. Remember, that again comes from f dash x over f of x. That's my logarithm differentiation rules. Now, at the point where x equals 2, because that's what it's asking me for, the gradient dy dx, or m1, or whatever you want to call it, is equal to a half. Beautiful. So the first part's been ticked off, got my gradient. The second part I now need to work on. So y minus y1 equals mx minus x1. So my y1 value in this case is log e2. So y minus, I'll put this a different color, log e2, or ln2, equals my gradient, which is that's what I did in purple, so 1 over 2 times x minus, and now my x coordinate, which we know is 2, and there we have it. So what you can see in the purple is my gradient, that's what we found originally, and the blue there is my coordinate they gave us, 2 log e2. Remember, if they don't give you both x and y coordinates, they have to give you the x1, but if they don't give you the x1, just sub it back into this formula. If I put the 2 there, log e2, that's where it comes from. Okay. Alright, so you can now put this into the gradient y-intercept form, which is what most people will do, I would say, or you can put it into the general form. It's up to you. General form, just multiply everything by 2 and make the x positive. Otherwise, what we can do is just expand the brackets out. So we get half times x is half x, minus half times 2 is 1, plus the log e2 on the other side. There we go, got my answer. So that's is the gradient y-intercept form. If you wanted to put it into general form, then what we'll be doing is we're timesing everything by 2, and make, if I times this by 2, we get x, bring that across, we get minus 2y, plus, so minus 2, and then plus 2 log e2, and that would equal 0. So that's again if that was in the general form, but you know, that's probably the easiest format to start off with. Okay, that leads us to the very last question, which is probably going to be one of the more challenging ones, although they're all pretty tough. Question 7, find the exact equation. All right, exact, so that's what we did the last one. If you don't use exact values, I guess you can use the actual log function, ln, on your calculator, but pretty much every time we do exact, so that's not really different. The normal, that is, okay, I say normal, I think this. m1 times m2 equals -1. It's asking for the equation, so I need to find the gradient, and I'm going to need a point. Now notice here, for my point, they've given me the value x equals 5, so I can put my 5 there, but they haven't given me a y value. This is where people get stuck. I do this at the beginning every time, just put my 5 back where the x is, so it's log e5. Okay. So all I need is my gradient, because once I've got my gradient, we're going to simply put it back into the y minus y1 equals mx minus x1. Remembering that the gradient will be the normal, not of the tangent. Okay, so dy dx. Again, it's just log ex, so it's no dramas, it's just 1 on x. We've been doing that. They might be a bit more challenging, but often not. Okay, so at the particular point we're looking at x equals 5, my dy dx, or my m1, I'm going to call it, is 1 over 5. Therefore, m2 equals negative 5. Now, where did that m2 come from? Remember, that is of the tangent, the gradient. This is of the normal. Now, if you're not sure, you can use that m1 times m2 equals negative 1. My m1 is 1/5 times m2 equals negative 1. So simply the opposite of times 1/5 is divide by 1/5, or opposite of divide by 5 is times by 5. You know, that's probably the easiest way to explain that one. So m2 equals negative 5. But if you remember the negative reciprocal, that's much quicker. But I've got my m value, and now it's just the same as every other question that we did there, we've done before, in terms of simply putting it into that equation. Y minus my y1, which is the log e5, equals m, which is negative 5, x minus my x1, which is 5. And now we can put it into either of the two forms that we've spoken about already. So y minus log e5 equals negative 5x plus 25. So y equals negative 5x plus 25 plus log e5. Or if you really want the general form, we can put everything to the left-hand side because we want to have a positive x value. So 5x plus y minus 25 minus log e5 equals 0. Okay, look, there's lots of questions there. Certainly, you know, I think you need to get used to the style of questions that you're having, these written questions. They're ones you're going to see quite a lot. But notice how, you know, they're all asking for the same things. You know, it's asking for either the gradient or of the normal or of the tangent, and asking you to find the equation. And that process is identical. The only difference between all these questions and things that you were doing last year with this stuff, the only difference that you're having at the moment is how to differentiate that equation. That is the only difference. Okay, just remember, when you're differentiating a log, okay, you're doing f dash x over f of x. You still need to remember your exponential rules, but also your VOOV, your product, your quotient, your chain rule. Those rules you need to remember and apply everything together. That's what makes this stuff difficult. But take every step at a time and you'll get it. I hope this was useful to you. Try some of the alternate questions. If you want me to do any of the other questions online, let me know. Have a great day.